Okay, recording. So I remind you Tuesday, not Tuesday, today's Tuesday, Thursday, we have the test. It's on the Flask. That's labs 8 through 15. And homework assignments 5 and 6, and labs 8 through 15 must be in by 11:59 p.m. on Thursday, March 31st to be eligible for full credit. You should do the labs, get the labs done before that, because they can be used on the test. My example can be used on the test. Your examples can be used on the test. Anything you find online can be used on the test. You can't communicate with another live person. The test is in person only, unless there's a circumstance that you convinced me you can't come in. Otherwise, you must be here. This test requires some setup. You can bring your own laptop, that's fine. You can set it up on the computer here in the lab. You should keep your usual seat and not take anybody else's seat who might already have the setup. Okay. The files, it's very sort of, the files have to be in the right place and the right thing has to be in the right file. So the logic isn't too hard for the most part, but there will be some issues if you don't know where things go. So please try to do as many of those labs as possible before Thursday. I usually get a bunch of things all at the last minute. So if you have a question, try to get physically in front of me. That's your best bet to get your question answered. And if you need to communicate with me by email, then make sure your subject says like help or question or something, so I can make some effort to get to it before the exam. All right, anything else exam-wise? Expect it to be 2 parts, not as many parts as the first test, more like 2 parts. One part will have probably a smaller interface, but might involve sessions and cookies. So sessions and cookies are important concept, so I want to test on that. But on the other hand, they're easy to stumble over, so I don't want all of the other things to be blocked because you have some error with a session that you can't track down. So it'll be something with a session, something relatively small, kind of a simple interface. There has to be something to remember, so there must be something that the user does to remember. Otherwise, why have a session or why have a cookie? But it'll be relatively simple. And then there'll be a more complicated trying to survey of all the different types of things. So I'll just see check boxes and radio buttons and drop-down lists. So expect to see somewhere across the test most of the different kinds of elements, HTML elements. Well, that's that. Okay. Any questions about anything for the recording? Any questions you have about the test? Any labs or homeworks you want me to go over? I see nothing. Okay. All right, so I will go on back to what we've been working on, which is SQLAlchemy. All right. One thing to do, as I see as I'm going through this myself, make sure you're organized for the test. Make sure you know, oh, here's my example with radio buttons. Here's my example with check boxes, or here's my example with just a little bit of everything. And well, lots of comments so I know what's what and what to do. So it's not the kind of studying where you need to memorize. It's the kind of studying where you need to organize and review a bit, but not like memorize stuff. All right. So we started SQLAlchemy in 16. We did a single table. We wrote a class and we installed and we wrote a single class. And with that class, then that corresponded to a table and managed the interaction with the database table for us. In 17, we added a second table or a second entity and also a second table. And there was a one-to-many relationship. That's one of the main types of relationship in a database. And this time around, in part one, we're just going to repeat that. We're going to have songs, then Beatles songs that go on albums that have first appeared on a given album. So that will be once again a one-to-many relationship, that a song is on one album, but an album contains many songs. What do I want to do? I want to write that out in Word to emphasize this way. Then I like you to express your relationships, not just that I like, that I insist on. So a song is on one album. Let me increase the font size there. That's good enough. And an album contains many songs. So when I have you express the relationships, I have you write the relationship, explain the relationship in both directions, always starting with the word a. And then when you get to the other side of the relationship, it should be either one or many. So this is the A song, or maybe we'll say the song is not just on one album, but maybe premieres. If I could spell premieres, is that how I spell premieres? So I'm not going to do any greatest hit albums. So a song premieres on one album, and album contains many songs. So that then the relationship between song and album then will be one to many. And that's what we're going to do. So the first part is just going to be a repeat of what we did the last time. And then I'm going to come along and add to my database the artists. And then the artists are going to write songs, and they often wrote songs in collaboration. So many of the Beatles songs are attributed to both Lennon and McCartney. And so then there'll be a relationship between song and artist. And so we will say, and I always start these with A, so a song was written, or you might say could be written, let's say maybe instead of was, maybe written by many artists. So, and then an artist writes many songs. So that is the way to express this relationship between songs and artists. And the word many there is twice. So this is a many-to-many relationship. Previously, up here in the song album relationship, the one, that's where we're going to put our foreign key. So we're going to say the song has a field, has a column that is a foreign key, and in that foreign key is going to be the album ID, identifying which album that song is on, because the song's on one album, so we can identify it with just the album ID. Down here, with the many-to-many relationship, I can't do that. The song was written by many artists, so I can't have just an artist ID, because there is more than one artist. And then I can't have, in the artist, I can't have the song ID, because the artist wrote many songs. And so in the many-to-many relationship, we end up with another table, which I'm usually going to refer to as a bridge table, but there are other words for that table. And so that'll be the new thing that we have to learn how to handle today. Okay. So, but first, let's do the reviewy part, just a different database than what we had before. All right, let's go there and then download it. I have some of the information in a data file, so I have that in static. And here I am, it's in 341, it's in, I think SQL2 is what I've been using for this class, and in the VENV that I made, and I'm pasting it, and it's app Beatles, there it is. Okay, so I'm gonna open up code. I'm going to go to open the folder, 341 SQL2 VENV. And it was app Beatles there. Okay. So again, as normal, it's what stays the same and what changes. Column is their name for a field. So that's, you're not gonna have a database without any field. So you must have the field. Integer is some number, or we'll use our IDs will tend to be numbers. So that's for that. String, the song names and the artist names and the album names and all that will be strings. There will be a foreign key, which will connect me to some other table. We'll have a session so we can interact with the database, and we will have some relationship. At least to start off with, we're going to have an in-memory database, because I'm going to run this all over again, and I don't want to be creating the songs all over again. So maybe I'll make a database, an actual file with the database in it the next time. But for now, I'm leaving it as in memory until I get everything settled. I'm starting off with the album class. It is extending our base class, or SQLAlchemy's base class. The name of the table over in the database is going to be album. I don't know, sometimes I put an S on the end, sometimes I don't, but we're going to have an ID, which is a column. The album, I'm making my own IDs here, because I have a file. Let me show you my files. I have albums, Beatle albums, and there is a some ID that I pre-made, the title of the album, and then some JPEG that I don't know what these JPEGs are anymore, but in case I ever find them, let's have them in the database. Then in Beatles songs, I have Beatles songs. There we go. I have the title of the song and then the code for the album itself. So because I had this information already in my data files, I want to stick with those. I want to stick with that thing as my primary key, and I did not use a number. Okay. So this time the primary key is a string. So that makes me responsible for it, but I already had it in my data file. And it's a primary key. The name of the album is a string, the image is a string, and album has a relationship to song. Remember then in the one-to-many relationship, the album has many songs. So that's not where the foreign key goes, but we're going to have a relationship there. So songs is the relationship to the, this is just the name of the relationship, songs. It's a relationship to the class song. Then we have the song class. It corresponds to a table in the database that I called song with a small s. This song will have an ID, which will be an integer. In my data file for songs, I had no numbers. I had no symbols. So I'm going to use an integer and let it auto increment. So to auto increment, I need it to be integer. It's the primary key. The song title is a string. The album title is a string, and it's a foreign key connecting to the album. Right? Album ID in song, album ID is a column, that's a string, that's a foreign key relating to the album underscore ID. This is a table. When I'm doing songs and saying the relationship song, the album has a relationship to songs, and that's the relationship to the class. Whereas the song has a foreign key, which connects to a table. Okay. It's confusing. You have to pay attention to what's the class and what's the table. Easy to get backwards, but I don't know, pay attention. And this had to be string because that's what it was up here. In the album, the ID was a string. So down here in the foreign key, it needed to be a string, so it matched what was in this table. This is all the normal stuff. Create the database, set up, establish the session. I'm reading a file. Those are my data files. So this is me establishing the path to be in the right location. I'm going to start with the albums because I have to establish the albums and their primary keys before I do the songs, because the song has a foreign key relating to the album. So I must do the album first. Okay, so I'm reading this file. It was comma separated, but it was .txt, but it's still comma separated. So I'm reading the file, I'm looping over the file. I didn't have any headers, so I don't have to skip the first line. I can dive right in. The stripping does, and it gets rid of any sort of blank space, the strip and the R strip. And I'm splitting on the comma. I can easily change that to vertical bars, to colons, to slashes, to, pay attention to the delimiter. I can easily change a delimiter. It shouldn't be something that hampers you and stops you in your tracks. Sometimes I have, as part of the data, a description of something. The description will be some English, and English sometimes has commas. So I can't always use comma as my delimiter. Okay, then the X0, after I did the splitting, it created for me a list. The 0th element was the ID. The first element, the element with an index of 1, was the title, and the image had an index of 2. And I'm adding it to the session. When I'm through the loop, I am done reading, then I commit and flush. I open the second data file. And again, I'm looping through. The second data file is for the songs. Also, again, no headers and comma separated. Looping through the file, stripping and R stripping, and then the make the one on splitting makes my list, and the 0th item is the title, song title, and the other one is the album ID. So that was here, the song title, then the album ID. Add the song when I'm done commit. Here I'm querying the database. I am using the session to query the album table. I am looping through all of the albums. And then I'm using the song relationship, the songs relationship that an album has. And then I am doing a nested loop, an inner loop over the songs for that album. This crazy thing here gets it underlined. That's going to underline this title. And it's \T is a tab. So they're going to be indented. And then when I'm done this loop, I'm printing a \N, so that's going to give me the blank line. Okay, let's. So there is my output. That's the output of the query. So I read the files, I created my tables, my 2 tables with my relationship. I read my external data files. I added records to my database. I queried it. I'm looping through the results of my album query. I never myself explicitly query the song table. I query album, but the SQLAlchemy handles for me the relationship to the song table. That's handled for me. So I don't have to write any explicit query of the song table. I don't have to explicitly worry about a join. That's done for me. Thank you, SQLAlchemy. And there you can see my very awkward little underlining and my blank line and my indenting for my tab. So my little bit of trying to make it look nice. Questions? So that's mostly for the most part, old stuff. Well, old from last week, from the last time we met. Now I want to add in the artist to this database. And then there's going to be a relationship between artists and songs. And that's going to be my many-to-many relationship. Okay, so where am I at? SQL Beatles many-to-many. And this is a new Python. So 341, SQL 2, VENV, paste it. The data files are overwriting, but the Python is a new file because I put _2. Okay, so we're adding in the artist. So there will be, I'm adding a new entity, but because that new entity has this many-to-many relationship with the songs, I'm going to be adding 1 entity, but 2 tables. That's the mechanism that makes many-to-many relationships work in a database, that there will be a bridge table. So I'm going to be adding 2 tables. One will be an artist, which I'll treat as a class. And then the bridge table, I'm going to treat just as a table. There is a way in SQLAlchemy to treat the relationship as this many-to-many relationship as its own sort of independent class. I'm not doing that. So I'm going to treat that bridge table as a table, but then use that bridge table in my relationship. Okay. So all that big comment is probably me saying something about what I just said. What am I importing? The normal stuff, except column, we know, integer, we know, string, we know, farm key, we know, table. I'm making the bridge table as just a table. And so I have to say I'm bringing that in and making a table. I switched the create engine because now this is my last one. So I'm not going to just make it in memory, but I'm going to make it, recall it in a file. I'm going to make the right table first, because when I have song, it's going to relate to artist through the table. And when I have artist, it's going to relate to the song through the table. So they both want the table to be there first. So I'm going to make the table, establish the table first. Okay. This term right table is just me naming it. That it is, that the relationship for me is that the artist writes a song or the song was written by an artist. So I called it the right table. That is not some database term. That is, that's nothing except my expression of this particular relationship, and it's writing of songs. And some of you will just copy fairly blindly what I do, and you'll call things that have nothing to do with writing the right table. It will work. But just understand that this has no meaning other than my attempt to express the relationship, that this is a table that establishes the writing relationship between the Beatles and their songs. But you can use that name, but there's no reason to use that. So it's available, you can use it, but there's nothing special about that name. In fact, there are times it will seem awkward, but you'll still use it. Okay. This bridge table is just foreign keys. It's possible for there to be other fields in a bridge table. Sometimes maybe a date or something like that. So there can be other things in a bridge table. For this case, there's not. It's just a simple table of artist ID and song. These are not the primary key for either. So artist is the primary key of the artist table. Song ID is the primary key of the song table. Neither of them is the primary key of the right table. You can, some people will, make a primary key, sort of an auto increment primary key for the right table. So that's a possibility. You know how to do that. Add a column, call it right ID, I don't know, and make it the primary key and make it integer so it automatically auto increments. You can do that. You don't have to. So that depends. That's a matter of taste. Do you want a simple primary key for your right table? I'm using, I'm not explicitly saying so, but I am using a composite key so that in this table, the combination of artist and song, artist ID and song ID should be unique. Each record in my database should be unique. So I should never say that, you know, Paul McCartney wrote this song, Michelle, and then repeat that. Paul McCartney wrote Michelle, because then I would have that same record in the table twice, and that's a no for databases, as we know. Okay. So if I had an auto increment, it would accept that, and it would just give it two different auto increment primary keys. So that's a matter of taste. I'm not going to say how you must do it. People will mainly just copy what I do. But if you want your right table, if you want your bridge table to have a primary key, that's of course acceptable. Okay. But again, I put this table first because once I get to song, it's going to refer back to this. When I get to artist, it's going to refer back to this. And so I wanted it to already exist for them. So when the Python is working through my code, it won't say, I don't know what the hell you mean by this table. It will have already seen the table and say, okay. So this is working ahead a little bit because it hasn't seen artist ID, but it's sort of happy with that. But if you start referring to a table that doesn't exist, it's going to complain. So it's a complicated relationship. You got to put something ahead of something else, and it's okay with the table first, and it's kind of not okay the other way around. All right. Here's the album. We've seen it before. It connects to a table that has the name album. It has an ID, which is going to be a string and is the primary key. There's a column, which is a string, which is the title. There's a column, which is a string, which is the image. It has a relationship to song. That didn't change. Here's the song. It connects to a table called song. It has an ID. This one's an integer, an auto-incrementing primary key called ID. There is a column, which is a string, which is song ID. There's a column, which is a string, which is a foreign key relating to the album, establishing the one-to-many relationship between album and song. That all was old. 53 is new. I'm establishing another relationship with song. Then I'm calling written by. Again, that's just my name for this relationship. It's a relationship to artist. And the relationship is through the right table. And then there's this like view only thing true that I just, I needed something that made it work. Okay, so we're using the same word relationship, but it's more complicated. Here I just said, with the one-to-many relationship, I just said I had a relationship to song. Down here with that was album to song. Now song related to artist, that's a many-to-many. So it's not just relationship to artist, but it's relationship to artist through the right table, through this secondary or bridge table. Here's the artist, a new class. The table name is artist. The ID, I'm auto-incrementing, so I made it an integer. I have a first name, a last name, and then I have a relationship to song that goes through the right table. Are we okay? We'll say okay. Usual, create the database, establish the session, go to the files, go get my path right for the files, read the files, make the albums. Read the file, make the songs. That's already done. I'm going to hard code. I didn't have John, Paul, and Ringo in a data file, so I'm just hard coding them in. So here's my artist, first name John, last name Lennon, and I add Paul McCartney, add George Harrison, add Ringo Starr, add. Commit and flush. So now I have my artists. I hard coded my artists. I got everything. I got other things from files. You can, if I say in like a lab or something that you must have something from a file, then you must have it from a file. If I don't say, then you're allowed to sort of hard code it. So I was lazy here and I hard coded my artists. You can debate yourself if there is a fifth Beatle or not, but I'm just going to go with 4. Okay. I'm also, here I am hard coding the right table. The right table is sort of like hard to deal with. So I'm just hard coding it here. So let's look at that table one more time. The table is artist ID song ID, artist, then song. There's no reason it has to be that. That's just what I did. Artist, song. So here is the artist, the first artist, John Lennon, writing the first song. I saw her standing there. Here's the second artist, Paul McCartney, writing the first song. I saw her standing there. Sometimes they wrote separately, but they both get credit. And so that's how we're working. Sometimes they actually work together. Sometimes they work separately, but both gave each other credit. That is, I'm inserting two records. I'm inserting a record that says John Lennon wrote I Saw Her Standing There, and Paul McCartney wrote I Saw Her Standing There. The second song is Misery. John Lennon wrote Misery, Paul McCartney wrote Misery. The sixth song is Ask Me Why. John Lennon wrote Ask Me Why, Paul McCartney wrote Ask Me Why. I have to get all the way to song 18, Don't Bother Me. That was written by George Harrison and only George Harrison. So he was not part of the normal songwriting team. So when he writes something, he gets the sort of individual credit for it. So that is me populating that table. Commit, as you know, actually puts it in the database. All right. I'm querying a song. I'm querying the song table. I'm getting the first song, which was I Saw Her Standing There. And then that song has a relationship to the artist, a many-to-many relationship to the artist, but this is just a single song. So there will be, I'm going to go to the first song, go to its written by relationship, and loop through and see that I Saw Her Standing There was written by Lennon and McCartney. I have my first, I'm querying the artist table and grabbing the first, so that's John Lennon, so that's why I called it John. And then I'm looping through the songs. So John wrote is my relationship. And so I'm looping through the songs that John wrote and showing the titles. So that's all I wrote, those two queries. Okay, so let me come down here and clear and run this. So here are my two little queries. I Saw Her Standing There was written by Lennon and McCartney. That was my first query. Lennon wrote the following songs: I Saw Her Standing There, Misery, and Ask Me Why. And they wrote a lot more, but I'm lazy. Okay. Now, this time around, I didn't use an in-memory database, but I did here Beatles. If you remember the last time we established our extensions, there is a SQLite, if I could spell, SQLite extension by Alex XCVZZ, which I have installed, that allows me to see SQL databases. Okay, so I think it's Control-Shift-P, and then I could search. Right now it's popping up for SQLite because that's one of the last things I use, but if I didn't have that, I could start typing it, and then it would give me this list. I want to open a database, and I have art from before and Beatles now, so I can say Beatles. And then if I go back to my Explorer, I now have a SQLite Explorer down there at the bottom. I can expand. I have 4 tables. I have albums. Let me right click and show my albums. Please Please Me with the Beatles, A Hard Day's Night. Right click and show the artists: John Lennon, Paul McCartney, George Harrison. Right click, show the songs: I Saw Her Standing There, Misery, Anna. And the right table is just going to be numbers. So that's not going to be very meaningful unless you know what everything is. But here it is that Lennon wrote the first song and McCartney wrote the first song and Lennon wrote the second song and so on. If you're working in an access database or something like that, you can say, when you show me this intermediate table, don't show me IDs, but show me something more meaningful. But that's not what's really there. That's just the interface sort of making your life a little bit easier. But this is what's really in the database, IDs. Any questions? What do you have to do? Same thing for the most part. Download, open. You're going to make a database of quotes, authors, and subjects. Okay. We're going to say then an author has many quotes. So somebody can say more than one thing worth remembering. But a quote's going to have one author. So we're going to find out who said it first and they get credit. And so here's my example. Mark Twain said some things. Okay. So this quote will have a Mark Twain ID as a foreign key because the quote has one author. So the quote has a foreign key relating it to the author table. The subject and quote have a many-to-many relationship. The quote may fall under many subjects. It may be humorous and about education or something like that. Don't let schooling interfere with your education. So that's funny, sort of, and about education. So that has, but humor has multiple quotes that are humorous. There are, this quote might be humorous and also about something. So it is, a quote may fall under many subjects. A subject may have many quotes. So that relationship is many to many. You're going to need a bridge table. And so you're going to have to set up like I just did with the Beatles. Then I want some queries, list the, give me and query the author and give me that author's quotes. Query a subject and tell me quotes for that subject. And then give me a quote and tell me the subjects for that quote. And what a lot of people have ended up doing in the past is they're not really paying attention to the fact that this relationship is supposed to be many to many. It will be clearer to you what you're doing and why you're doing it if some of your examples have more than one subject. Then it will be clearer why you're doing what you're doing. If your example quotes all just have a single subject, that's possible, but you're not sort of explaining to yourself in your example the reason for the many-to-many relationship. Questions? Any questions for the recording? Okay, I'm going to stop recording.